This screencast is going to focus on connective tissue, the second of the main types of tissue in the human body after the epithelium on the first screencast. Connective tissue, as these bullet points tell you, it's found everywhere in the body. It plays a role of really support and a lot of cushioning and protection in its function. But there's a lot of different types within it, and and each one of them plays an important role in the structure of the human body. The characteristics of connective tissue. Firstly, there's variations in blood supply, meaning that some of the connective tissues in the body have a great supply of blood. They have a lot of arteries that nourish them with nutrients as well as oxygen, and some of them are completely avascular. They don't have any direct blood supply. And because of that, some types of connective tissue are actually very poor healers. If there's an injury to that tissue, if there's some sort of physical damage, it tends to remain that way because they don't receive nutrients and they don't receive oxygen. Therefore, they don't regenerate or reproduce very well. But probably the type or the characteristic that we're going to focus on is the presence of a substance called extracellular matrix, or just alone we talk about the matrix. As the name implies, extracellular, this is material that's typically secreted by the cells, but it is indeed found outside of the cells. So it's actually a part of the tissue, but it isn't made of cells themselves. When we were talking about epithelium and epithelial tissue, that was all of these epithelial cells that were jam-packed tightly together. In many types of connective tissue, the cells aren't jam-packed at all. In fact, they're a lot of times spread out and distributed, but there's this other material that we'll talk about a little bit more later that is outside of the cell, but it plays a very important role in the tissue itself. So this matrix, it has two main elements. The ground substance, as it says, mostly water with some other protein, some other things dissolved in it, but it doesn't have a very textured consistency at all. It's very, very smooth and typically watery or gel-like. But the fibers, depending on the type of fiber in the tissue, the fibers really distinguish the type of tissue, and the extracellular matrix helps you identify the type of tissue. There's three main types, and what we will focus on are probably these first two. These collagen white fibers, they're called white fibers, though they typically show up in different colors, or elastic or yellow fibers. The collagen fibers are typically for strength. They give a lot of strength, tensile strength to resist stretching and turning and twisting. And the elastic fibers actually allow the tissue to change some shape and then, like elastic, spring back to its original form. Reticular fibers are rather rare. They're only found in reticular tissue, but which we won't talk about here. But those are the two makeups, the two components of the matrix. The first type is bone, otherwise known as osseous tissue. But bone is the hardest, it's the most firm of all the types of connective tissues. And that's because of the matrix we just talked about. The extracellular material is made out of calcium salts, which are hardened, which makes sense with the structure of bone. So of course the function is to protect and support other tissues and organs of the body. But this is what it looks like. The main cells, or in other words, the primary cells, are called osteocytes, and they are found in, kind of a fun word to say, lacunae. These are essentially cavities. They're big bubbles that house the cells inside of them. But if you look at bone tissue, it's easy to identify this. Each of these structures kind of looks like a tree trunk, cross-section of a tree trunk, or maybe a bullseye or a target. But those little dark structures that you see are actually the cavities where you would find the cells. And all of the tannish, yellowish, beige color, off-white color structure that you see is indeed the matrix. The next type of connective tissue, a very common one in the body, is cartilage. Now there's actually multiple types of cartilage. The first one is called hyaline, and that word part, hyaline, or hyal that you see there, actually means glass, and it's a very glassy appearance, or like smooth, slippery surface. It's the most common type. This is what you would find separating one bone from the next in the body. It provides a great frictionless surface for one bone to slide or move or articulate with another. This is also what you would find in a fetal skeleton. Actually, bone tissue, as you develop, is replaced, the cartilage, hyaline cartilage, dies off and is replaced by bony tissue, and that's how your skeleton forms. Here's a photomicrograph, or a picture of hyaline cartilage, and as you can see, these are the primary cells are called chondrocytes. Chondro means cartilage, chondrocyte, cyte means cell, and they are also found in lacunae, which are the little bubbles or the little air sacs or the little cavities which house them. But in between all of these cells is called the matrix. It's the extracellular matrix. And the appearance of hyaline cartilage, it is very, very smooth. You won't see any fibers. In the next type of cartilage, you'll see a lot of fibers, and you'll be able to distinguish the difference. Here's the second type of cartilage, called fibrocartilage. As the name implies, there are tons of fibers. In fact, in the matrix, as you can see, in the matrix there are an abundant number of fibers. If you would take these little squiggly things in between the cells away, it would again look a lot like the hyaline cartilage that you just saw. But fibrocartilage, lots of fibers. It's probably the focus point or the focal point of the slide, and gives it its name. Dense connective tissue, again, as the name implies, this is very tightly packed fibers and connective tissue. The main function of them, or the locations that you would find them, these first two, tendons and ligaments, have this very dense connective tissue that makes up those structures, and that's why tendons and ligaments are actually very, very strong. The fibroblasts are the primary cells, and a lot of the collagen fibers, as you can see, it looks like you took all of the cells and the collagen fibers and put them in a vise and packed them together. Again, that's why tendons and ligaments are very, very strong. They are very tough to break, to rip, to tear. However, we as humans do a lot of things that tear ligaments and tendons. Namely, a lot of things that we do in sports and athletics. The body really isn't engineered to do that, and we can often injure these things. A type of connective tissue that is actually referred to as loose connective tissue, and you can contrast it with the dense connective tissue and see where it gets that name. But this type is called areolar, kind of like those people that sell houses, but missing a syllable there. Areolar. Oftentimes mispronounced, but you can practice it yourself, I guess. It's very widely distributed in the body. It plays a cushioning and soft packaging role. As you can see there, you've got collagen and elastic fibers going every which way, with these small primary cells that you can see kind of dispersed there. But this is a very good packaging, very good cushioning tissue. It's compressible and it returns to its shape. Adipose tissue, a fancy name for fat tissue. As you can see here, it's a lot of the cells that are jam-packed together. The white substance that you see here, it kind of looks like a type of epithelial tissue that looks like it's a free surface and that it's free space. But as you can look in the cartoon drawing, these are actually jam-packed full of lipids, or in other words, fat molecules. So as one actually grows fat tissue, what you're doing is you're producing, or you are storing, more individual fat molecules or lipid molecules inside of these cells, and they sort of keep on growing. And the last type of connective tissue here, as we've kind of run the gamut from a very firm and hard extracellular matrix in the bone tissue all the way to the blood, which has a liquid or fluid extracellular matrix called blood plasma. But the blood cell itself, you can see the primary cells here. You've got white blood cells, and all of these uniform looking cells are the red blood cells. In between them, all of that substance would be the matrix, which we know specifically is the plasma. So in conclusion, probably the number one thing that we would use to identify connective tissue is to look at the matrix. Remember that in epithelial tissue, epithelium now, the first main type of tissue in the human body, all of the cells were jam-packed together. In connective tissue, the extracellular material here is one of the main features of the tissue itself. So the cells, the primary cells, are often kind of scattered about, and the matrix, either the ground substance, the smooth ground substance, or all of those fibers are an easy thing to look for and identify. The second thing to probably use the most is then to identify what type of fiber you see. Are there fibers present, and then what type do you see? And as you practice identifying those tissues, it'll become easier and easier to recall them.